Hi, I'm going to introduce you another interesting pattern mining approach called pattern growth approach. This approach is represented by an interesting algorithm called FPGrowth. Let's look at how this algorithm works. The general idea is first we mine the frequent single items, and then we partition the database based on each such item. Then we recursively grow frequent patterns by doing the above iteratively or recursively for each partition database, also called conditional database. To facilitate efficient processing, we use a new data structure called FPtree. The whole mining can be summarized as follows. We recursively construct and mine conditional FP trees until the result FP tree is empty or until it contains only one path. This single path will generate all the combinations of its subpaths, each of which is a frequent pattern. Let's look at a simple example. For this transaction database, it has only 5 transactions. Each contains a set of items. So we can scan the database once, find the single item frequent pattern like the following. Suppose the minimum support is 3. We will be able to find the following frequent single items. Then we can sort the frequent items based on its support frequency in descending order like this. Based on this, we can construct a tree by first constructing a header following this order, then scan the database. We can construct this tree as follows. For example, if you look at the first transaction is FCAMP, so we construct FCAMP with only support as 1. Then we get FCABM, we constructed this FCABM, and this part support becomes 2, this maintains to be 1. Then we can go this one, one by one, we will construct the following tree. Then to mine this tree, we can use divide and conquer and do it recursively. We can do it like this. For each such tree, we can construct this pattern base. We call P's conditional pattern base, M's conditional pattern base. Let's look at how P's conditional pattern base is constructed. So you probably can see P is the leaf of the node. You only look up. You get FCAM. The support is 2 because P occurs together with this branch only twice. That's why you get FCAM2. Then for the same reason, you look at the other P, its CB happens only once together with P. That's why you get CB1. Then if you want to look at M's conditional database, the philosophy, you were thinking the patterns having M but not having P because P already been taken care of by the P's conditional pattern base. So you look at the M's conditional database, actually you also look up, you get FCA. So for this branch, they occur twice. That's why you get FCA2. For the same reason, you look at this M, you get FCAB1. So you get FCAB1. You can do this on and on. Then with this, you can get it into transform the prefix path of P. You get the following. Then the remaining task is just mine this conditional pattern base. For this conditional pattern base, we mine single item patterns. We construct this FP tree and mine it recursively. For example, for P's conditional pattern base, you will get only C3. The reason is F, A, M, and B, they never occur more than 3 times, so they are out. They are not frequent. You only get 3. But for M's conditional pattern base, you can see FCA really occurs 3 times. The B only occurs once. Then you get FCA3. And B's conditional pattern base, you can see none of them actually pass the support threshold of 3, so it's empty. So let's just look at, of course, you will get A and C's pattern base like F's3 and FC3. Actually, for this single branch, you can dump all the possible combinations there support all three. But we just look at in the recursive way how we can mine this pattern base. For this pattern base, you probably can see, you can say for A's conditional pattern base, you'll get this, you get FC3. And for C, you get F3. You can see that's the same thing. Then for this particular AM conditional FP tree, you just take a C, you say C's, that means AMC or CAM. Their conditional pattern base is only F3, you get this. Then you can dump all the patterns, like this. For single branch, essentially that's the same thing. You will dump all the patterns, like all the possible combinations, they are all three. You probably can see if you get a single prefix pass, you actually can partition this into two parts. Like this pass, you can mine it, and this part you can mine it, then you can just concatenate the pattern results. What about this tree cannot fit in the main memory? If it cannot fit in the memory, we can use database projection. That means we project the database based on the patterns, based on single item set. Okay, so then we can construct and mine this tree for each projected database. So we can have parallel projection or partition projection, two different methods. The parallel projection means for this one, you will get a F4 projected database and F3 projected database. For example, for this first string, you will see GH, suppose it's not frequent, only F's are frequent. You will get F4's projected database, you get F2, F3. Okay, then F3's projected database, you get F2. That's the one. Then every one of these projected databases is independent of the others, so you can mine them in parallel. But then you also can have partition projection. Partition projection, the general philosophy is for each string, you only put into one place. For example, this one contains F4, you only put F2, F3, but you don't put this F2 to F3 projected database. When you finish mine this F4, when you do this projection, then you think this one is related to F3, you will put this one into F3. Okay, so that's just different choices, for different partition or parallel projection. It's just different way of implement it. Thank you.